still have some questions on factoring, on how to factor. We're going to do more factoring today. Okay? We're going to do more factoring today. Factoring is not the be-all, end-all way, because what we're trying to get to is solving. It's not the be-all, end-all way to solve quadratic functions. It's not the end. Because we're going to go over at least another 4 different ways to solve quadratics that does not involve factoring. So we'll have about 5 total. 2 out of those 5 work every single time. The other 3 don't. Factoring is not one of the ones that works every single time. Now, on your note sheet, you probably noticed the zero product property, yes? So a few of you who are in ACT prep, do not answer this question. You already know the answer to it. What is the value of A? 0, right? Because 0 is the only number when multiplied by anything else is 0, yes? So I'm going to replace 5 with, so what is the value of B or A? Well, for this here, one of them has to be 0, because any 2 things multiplied together that give me 0 means that either A is 0 or B is 0. One of them has to be 0, yes? If the product of 2 expressions is 0, then one or both of the expressions equals 0. That is a zero product property. So why are we starting with that? That's probably one of the questions. ACT prep kids know this because we covered it yesterday. This here, kind of like how we had this here, and we've been factoring. When I finish factoring, I've got 2 things multiplied together, yes? And when we are solving quadratics or any higher degree polynomial function, we are wanting to know what value of that variable will make the equation equal 0. That's what our goal is. So when we talk about solving higher degree polynomial functions, or you've seen that or heard that probably in some TV show, they throw it out there. This is what we're doing. We're trying to see what value, so for here, of k, will make this thing equal 0. I have 2 things multiplied together, yes? So according to zero product property, it means either that k plus 1 is equal to 0 or what? One of these 2 has to be 0. Because if one of them is 0, then the whole thing will be 0, because we have 2 things multiplied together. Solve this for k. What would we do? Minus 1 from both sides, yes? And we would get that k is equal to -1. And if you're wondering it, I switch for k. For some reason, I always switch between capital and lowercase. They're the same thing. We're just talking about k. We're not in a chemistry class, so it doesn't matter. Capitalization, lowercase, and the big ideas math, it will. You don't want to switch from capital to lower. It should be all lowercase for big ideas math. So here, just k is equal to -1. Questions on this here? Let's do the other one. What would we need to do for this here? Add 5. We're done. Because we're trying to find the values of k that would make this function 0. Because when k is -1, well, -1 plus 1 is 0. So the whole thing would be 0. The same thing is true with 5. Because 5 minus 5 is 0. The whole thing becomes 0. Questions on this here? Let's look at this one here. Let's look at this one here. So for this one here, we do have 2 things multiplied together to give me 0, yes? So we can set each one of these equal to 0. Because according to the zero product property, when any 2 things multiply together give me 0, one of them has to be 0. I don't normally say both have to be 0. It's either one or the other, because as we saw there, the values differed, didn't they? The only way it will really be a both is if the statement here, 2m plus 3, was the same as the other one. So if I had 2m plus 3 and 2m plus 3, then they would both be 0. But in most cases, like this one here and the one before, we'll have two values. All these quadratics will have two values. Sometimes they will not be unique. Unique means different. Sometimes they'll be the same. So what do we do first? We would subtract 3 from both sides, which would give us that 2m is equal to negative 3. And then what? We would divide both sides by 2. M is equal to negative 3 halves. And that's it. Now, luckily, big ideas math should be able to determine the difference between negative 3 halves, negative 1.5, and negative 1.5, because those all three are the same answer. So on a test, I will take any one of those three. Any one of those three will work just fine. Okay. So looking at this here, what would we do first? We're going to subtract 3 from both sides, which would give us 4m is equal to, then we divide by 4. M is equal to negative 3/4. And that's it. That's it. Now, there are some calculators that will solve these for you. But literally, you just have to type in the starting equation, and it'll find the factors. It'll factor. It'll actually find the zeros. It'll solve everything. Those calculators are normally like the 160, 180, and they're not allowed on any standardized test, so we don't use them. But this is all we have to do here. So are we good with this here? So we feel comfortable with this, yes? So we feel comfortable with this one here too. We should, hopefully. Because if we have it as two sets of parentheses multiplied together equals 0, we said each one equal to 0, yes? It'd be nice if we've been doing that, right? What we've been doing the last 2 days. That's why we went over it for 2 days. Because what we do is we take this thing here, we factor it, and when we factor it, we have two sets of parentheses being multiplied together, yes? Two things being multiplied together equals 0. Set them equal to 0 and solve. So we'll factor. That's what we're going to do here. So we look for a greatest common factor. Is there a greatest common factor between these three terms? So we move on to step 2, which was 3 spots, 3 spots equals 0. Equals 0. So we look at the constant term, it is positive, so the signs are the same, and they match the side of the middle term, which is? So we have positive and positive. Factors of the first and third term. Well, the factors of x squared are, well, factors of 21. 1 and 21, 3 and 7, and I think that's it. So which two do we want to use? 1 and 21 or 3 and 7? 3 and 7. Now, when you check this here, because at this point, when we were doing them the last 2 days, we wrote the check right underneath it. Don't write it underneath it. Because if this works, what did we do next on the last two? We solved right below it. Yes? So we don't want to put the check to making sure that we factored this correctly underneath it. Put it to the side. So I would write the check to the side, and I'm not going to draw the lines. I'm going to draw the lines in my head that we normally did to connect the two. So mentally doing x times 7, which is 7x. 3 times x is plus 3x, which gives us an x, is what we wanted, yes? So I do the check to the side of the paper so it doesn't get in the way of the work as we're solving, because this here did work, yes? So these are our correct factors. And because they multiply together to give me 0, it means that x plus 3 is equal to 0 and x plus 7 is equal to 0. So I do want to leave some space below it so I can write that next step and everything doesn't get all kind of messed up. Everything looks the same. Any questions on this here so far? You feel good with this so far? Let's solve x plus 3 first. What do we need to do? Yes. And I get x is equal to, I'll do the same thing for the other one. We're going to and that's it. That's all I have to do for this here. Any questions on this here? Any questions on any of this here so far? So that's all we have to do here. So we found the two values. We found the two values of x that would make this function equal 0. We found the two values that would make this function equal 0. Questions on this here? So hopefully, this isn't too much harder than what we've been doing the last 2 days. It's just adding one more step, yes? Because normally we would stop once we found that the factors are, but now we're going on and solving it. Any questions on this here? Any questions on any of this here so far? I'm going to skip that one and move on to this one. This one here, because I have a feeling y'all can do number 4 if you want. You can work that one if you want, and if you want me to check it later, I can. I want to look at this one here because I have a feeling some of you all are saying this is way different. We need a different method for solving this one, yes? Probably because it looks different. Let's just try the steps that we've had and see if that works. So our first main step was determining, is there a greatest common factor? There is one, it's 3. Because 3 out of 3 n squared will leave me with n squared. 3 divided by 75 is 25. In our next step, 3 sets of parentheses and 3 sets of parentheses. Now you might be looking at that and saying, well, we don't have a middle term. That's going to kind of probably mess with us with the sign. Because if the constant term is positive, the signs are the same and they match the sign of the middle term. We don't have a middle term. But what is the sign of the constant term? It is negative. So the signs are opposite. So when the constant term is negative, the signs are opposite. Now we focused a lot on when the constant term was positive, on how that works. But if we have a negative and a positive that multiply together, they give us a negative, yes? Or a negative and a positive, or positive and negative. The signs have to be opposite for the number to be negative when we multiply them together, yes? Because that's the only way that we get a negative number out of multiplication. If one number is positive and the other is negative, that's the only way it works. So that's why this is opposite. What are the factors of n squared? Well, n and n. We only have one choice, yes? How about 25? 1 times 25 and what? 5 times 5. We have these two here. Yes? What do we think? What do we think? 1 and 25 or 5 and 5? Let's try 5 and 5. n times positive 5 is 5n, yes? Negative 5 times n is negative 5n. What is 5n minus 5n? It's 0, isn't it? So do we have a middle term? No, because they cancel out, yes? This thing here actually has a special name. This is the difference of perfect squares. When we have two terms that are both squares, because n squared is n times n. 25 is a perfect square. It's 5 times 5, yes? And they're being subtracted. The difference of perfect squares will always work out like this. So when we come back on Monday, there are special factors. One set I'm going to ignore because trying to memorize the rule is actually more work than just doing what we do here. But these here work out specially, and we're going to look at those more closely. Because they always work out to be this here. So we have two things multiplied together, yes? Is there any way that I could plug a number in that would make 3 0? I mean 0, but there's no variable with 3, is there? Well, no, it's just 3, right? So whenever we have a scalar out front, just a number, when we solve, we almost ignore it. Because the only values that will make it 0 are where the variables are at, yes? There's not a variable out here with 3, so there's no way that it'd become 0. So we're really looking at where n minus 5 is 0, and where n plus 5 is equal to 0. These are the two places we're looking. The only reason I would worry about the scalar or that number that we factor out is if there is a variable with it. So if it had been, for this case, 3n, then we would look at where it's equal to 0. But here, since it's just the number 3, it's not a big focus for us. So to solve this one here, we would add 5 to both sides and get n equals 5. And then the other one we would subtract 5, yes? So we'd minus 5 here. We get n equals negative 5. Any questions on any of these here so far? How do we feel about these here? We feel pretty good? Yes, for the most part? How do we feel with these here? Pretty good? So it's using a lot of the steps that we've been doing to solve these here. Looking at 6, 7, and 6 or 7. Actually, let's do 2 off this page because I think we're pushing time a little bit. We'll finish this up a little bit. Which one of those looks like it'd be nasty? A really hard one to solve out of those 5. Probably 8, 9, or 10. Which one of 8, 9, or 10? 10. So with any of these here, again, some of the numbers look big, some of the numbers are big. But when we're solving this here, what do we want this thing to be? We want it to be equal to 0, yes? Let's make it equal to 0. Let's move everything from all onto one side. Now here, I'm going to subtract 7n squared from both sides. I'm going to move everything to one side. So whenever you see an equation, a higher degree polynomial function, so here, where a variable, when we have all the same variables in an equation, and the highest exponent is greater than 1, so we actually have a 2 or 3 or 4 going up, we want everything on the same side. And as I'm thinking, there's only one exception to this rule, and we'll see it later. And I'll point it out later, but it still works. We want everything on the same side. So what we'll get here is 0 is equal to negative 7n squared plus 14n plus 21. And when we rewrite this, I really want the exponents to decrease in order from left to right. So here, since 2 is the biggest exponent, we want it to go first, and then into the first, and then the number with no end. We want it going down. We want it decreasing. So that's the first main step. Now does this one here look like the ones we've been doing a little bit, except for negative 7. But that's what we do. On 8, 9, and 10, we get everything to the right or everything to the left. We want to move everything to one side. And then we continue on as normal. Is there a greatest common factor between all three terms? 7. And I'm going to pull out negative 7. Because I want to try to keep the first term, the term in front of the number with the square, positive. I want to keep it positive if I can. So negative 7 out of, well, that just leaves me with n squared, yes? Since I'm pulling a negative out also, this is not going to be plus anymore. It's going to be negative. 14 divided by 7 is n. It would be minus 3. It would be minus 3. Now that we've got all the common factors out, two sets of parentheses. The constant term is negative, so the signs are positive and negative, opposite. The factors of n squared are n and n. What are the factors of 3? 1 and 3. Yes, we only have 1. Which one do we want to make positive? Which one do we want to make negative? The one positive, or? So we'll check it. N times negative 3 is negative 3n. 1 times n is plus n, and this gives us negative 2n. That's what we wanted, yes? Two things, well, 3. We're not worried about the negative 7. But we have two things multiplied together that equal 0. So either n plus 1 is equal to 0 or n minus 3 is equal to 0. One of these has to be equal to 0, yes? What do we need to do this side? We need to subtract 1 from both sides. And when we subtract 1 from both sides, we get n is equal to negative 1. Here we wouldn't subtract 1. We're going to add 3. And we get these two here. And that's all we need to do for this here. That's all we need to do for this one here. Any questions on any of these here? Any questions on anything that we've done so far? How do we feel with these here? Feel pretty good? If for some reason when you're doing this, because the assignment, if you want to check it because it's saying they're both wrong, if you plug it in for n, or plug the numbers back in, and simplify this side here, so if I plugged in our values for n squared and n, it should equal what? 0. If it doesn't equal 0, it's not one of the values. It's not one of our values. Any questions on any of these here? Do we want to look at this one here? Yes? Looking at this here, is it equal to 0? No. So we need to make it be 0, yes? Now it doesn't matter which way I move it. I can move all three of these from the left to the right, or I can move the one from the right to the left. Probably going to be easier to move the one, yes? So I can subtract 8v from both sides because, again, we're just moving it over. We're wanting to get it to equal 0. Because 8v minus 8v is 0, yes? So we have it equal to 0. Well, we have 3v squared. 36v minus 8v would be plus 28v. 49 is equal to 0. So if you want to type some of these calculations like 36v minus 8v in the calculator to see what it is and make sure you got it right, do not type v. Don't type v into the calculator because these calculators have to have a value for it. So really what we're doing is 36 minus 8, which will give us 28, and we have the v with it. So we got everything to one side, yes? Now we need to solve for the value that would make this 0. So is there a greatest common factor between these three? Well, no. 3 won't go into all of them. Since 49 is positive, the signs are the same, and they match the sign of the middle term, which is, so both of these would be positive. We're going to have v and v, yes? Because that's the only way we get v squared is v times v. The factors of 3 are, well, 3 and 1, yes? We good with this here so far? 49 is 1 and 49, or 7 and 7. What do we think it's going to be? Is 49 bigger than 28? We don't have any subtraction to bring it back down, so that's probably not going to be it. And it isn't it. It's going to be 7 and 7. It is going to be 7 and 7. So these here are the factors, and if we did it, it would be 21v plus 7v, which is 28v. So it does work. This does work if we check it. So we have 3v plus 7 equals 0, and we have v plus 7 is equal to 0. Because again, our zero product property tells us that because we have two things multiply together that equals 0, one of them has to be 0. And we can solve. So for this one here, we would subtract 7 from both sides first, which will tell us that 3v is equal to 7. And then what we would do, we would divide by 3 to get that the value of v is 7/3. And it would be negative, yes, thank you. Because it should be negative, thank you. And the other one, we would subtract 7 and get negative 7. So we have negative 7 and negative 7/3 are our two answers for this here. Questions on this here? Questions on anything we've done so far? So are we good with all of this here? Yes? Okay. I have one last statement, one last thought I do want to talk about, and the bell is going to ring before I finish it, okay? I'm going to tell you that in advance. It is not always going to be the case that the variable goes first. It is not always going to be the case that the variable goes first or is in the first term. There is nothing wrong with taking this here and rearranging them so that the variable is first. There's nothing wrong with that. Can y'all see this here? Now the key thing to watch out for is if it is written like this here, the sign in front of x squared needs to be what? Negative. We take the sign with it. So whenever we rearrange them, if the sign in front of it is minus, we have to take the sign with it and rewrite it like this here. Does that make sense? So it's not always going to be the case that we have it with the variable up front. Sometimes we have to make it so the variable is up front. Okay? So that's what I wanted to say with that there. Now, the homework assignment